What's up?
What's up?
What's going on?
It's the day 5 of Virtual Measurement Conference.
Oh, this place again.
I have a better idea. Let's leave this place and explore Slovenia.
Yeah, let's go to Triglav and explore our beautiful mountains.
I mean, let's go! Guys! Where are we? Whoa. Oh my god, I think we are lost again.
No, we're always up for a challenge.
Empty spaces, what are we living for? Abandoned places, I guess we know the score. On and on, does anybody know what we are living for? Another hero, another mindless crime behind the curtain in the pantomime. Hold the line, does anybody want to take it anymore? Show must go on. Show must go on. Yeah. Inside my heart is breaking, my makeup may be flaking, but my smile still stays on. Whatever happened, I leave it all to chance. Another heartache, another failed romance. On and on, does anybody know what we are living for? I guess I'm learning, I must be older now. I'll soon be turning around the corner now. Outside the dawn is breaking, but inside in the dark I'm making to be free. Show must go on. Show must go on. Yeah. Ooh, inside my heart is breaking, my makeup may be flaking, but my smile still stays on. My soul is painted like wings of butterfly. Fairy tales of yesterday will grow but never die. I can fly, my friend. Show must go on. Show must go on. I face it with a grin. I'll never give it in. I'm with a shine. Ooh, I tell you, Bill, I'll overkill. I have to find a way to carry on with a show. Show must go on.
Welcome to the last day of our virtual measurement world. It was a great pleasure that you were with us for the past month. Today we will present the Dewesoft company, then we will look into monitoring solutions, and we saved the best for the last, customer stories. I would like to invite on stage Herbert Vernik, VP of Sales, Dr. Jurek Knez, President, and Andrej Orožen, General Manager of Dewesoft.
Hello Jure, hello Andrej. Today we welcome you all to our fifth and last day of the measurement conference. At this point, we want to thank all visitors who joined us the last 4 days. On average, more than 700 scientists and engineers per single day. But who is this company, Dewesoft, that gets so much attention? Today Dewesoft has approximately 250 co-workers all around the globe. But Andrej, how did this success story start?
I met Jure for the first time as a young engineer in one of the companies. We start to work together on the local market, and solution bring us to the useful software package, and then development starts with innovative ideas, and he became the youngest doctor in Slovenia. And after we start the company, he started to share his knowledge and innovative ideas and the talent to the young engineers who joined to the company. You know how it starts, Herbert. You were one of us founders.
Yeah, actually we met with Andrej first as competitors on a project in Slovenia for measuring vibration on big fans. And really soon we realized that we could be much stronger together. So we started to cooperate, working from project to project. This is how everything started. That slowly general purpose data acquisition software was developed, which was then offered worldwide. Herbert, you know that very well. You were promoting it heavily already from the start. And that was actually the start of Dewesoft company.
Yes, I remember well. Dewesoft headquarters here in Slovenia did grow from 10 people to more than 100 people in the past 10 years. It is amazing to see how fast that did grow.
Made in Europe from design to final product under one roof. At Dewesoft, we have everything at hand, from electronic manufacturing to production of circuit boards, tool shop milling centers for chassis production, assembly of instruments, and fully equipped calibration labs. So from the bare components, our instruments are fully made in Europe according to our high quality standards.
The mechanical tool shop is located approximately 2 kilometers from here in the mountain. How come that it is there?
People are the most important for us. What is needed the most is knowledge and passion for work. We started with mechanical production in 2007, one machine. Boštjan gave us space to place it on his farm. Then we bought a second and the third machine, and slowly the cows needs to go out. Boštjan was professor in the school before we started the whole tool shop story, and now he is teaching our co-workers about the CNC. We have now 12 machines, and all parts from the instruments are produced in that tool shop.
Yes, I remember well the first steps in the tool shop. It was a great time. But you also started with the electronic pick and place production in-house. Isn't that complicated? Does this make sense? There are so many professionals and inexpensive offers for that all around.
Yeah, Herbert, that is true. We have actually been working together with years with partner Eltek for electronic part assembly, but we wanted even shorter delivery times as well as perfect quality. So we invested in a very modern production line where all our PCBs are assembled today. Of course, still in cooperation. Fully automated quality control and full traceability give us a great base for best possible quality.
That's understandable. But also the development groups are growing further. How to qualify for R&D, research and development? How do you find the right qualifications? We have really a lack of engineers almost in all European countries.
Yeah, Slovenia is no exception. Engineering, especially in our field of work, is a big issue. First of all, we want to be a #1 choice in our valleys for young engineers with all education and mentoring programs, including the Business Incubator Catapult. The doors of Dewesoft are open that young entrepreneurs can use our testing and production capabilities. Therefore, at our facilities, a lot of new ideas come to reality. We are also working very closely with universities and have small R&D offices in Ljubljana and Maribor.
The biggest value for the company is the product knowledge. We have been developing our software suite over the last 20 years with an excellent software team specialized in different application areas. We implement continuous testing of software and firmware, making the software releasable every 4 hours. The in-house electronics development team designs analog amplifiers, instruments, and accessories together with a mechanical chassis team. We have in-house labs for electrostatic discharge, electromagnetic compatibility testing, power supply burst, power supply surge, temperatures from -40 to hundreds of degrees Celsius, shock up to 1000 G, and vibration up to 100 G testing to make sure our instruments meet the highest standards.
Okay, when I see to production, we have more individual, more handmade manufacturing than a mass production. Isn't that very expensive?
Well, we are going more and more in a mass production. Some years ago, we started with single project and we produce it in Rolls-Royce style. Now the quantities are bigger. We need to grow with that. We developed a strong ERP system, perfect traceability. We design everything in without cable connection style. We still design instruments in cooperation with customers, but on production we need to be faster. We need to deliver in a short time. The time is money for us and also for the customers.
Yes, it is. Jure, I think you did a great job when you started to rebuild the complete marketing strategy. I remember after 13 years building up the brand Dewesoft, you just changed logo and outfit. Later, we changed from technic datasheet-based style to real attractive marketing.
We always created instruments with passion. I got the question years ago, why do we take so much care about the outside of the instrument? Why is not just a plain sheet of metal? I answered, because we can, and because we also want that the instruments are looking just perfect. And the same is with marketing. We want to express the special passion for data acquisition with our general appearance, with web page, with brochures, with trade shows. And this virtual conference is a great example. In the lack of other options, we wanted to bring the news and educate in our own style via the internet.
Can you tell us a little bit more about how do we ensure quality in hardware and software and complete solutions?
First, or at the end, usually is the software. We tested over thousands of automated tests. We need to be sure the new version is stable and without errors. Hardware tests are done on our shaker, drop test system, or thermal chambers. We have a nice high-tech calibration system procedure, and we are close to getting in-house 17025 standard. Again, I would like to mention full traceability of components and also traceability of tests. We try to be good, and we are running to be every day even better.
We have an agile software development strategy. We do code reviews, and we are doing more and more automated testing in the darkroom. Of course, also classical testing is still very important.
We do follow ISO 9000 and ISO 14000 quality standard, but we see this as just the start. Each instrument is thoroughly checked through our in-house calibration services. The same calibration services are available in our subsidiaries in all major countries. Each instrument we build has a unique serial number. With this serial number, you can search on the web for the instrument's calibration history, but it also provides traceability for each part, down to the smallest resistor or capacitor, when it was purchased, from which production lot, with all the details about the component specification. The software is always changing. Our customers request new features on a daily basis, so we invented the dark room. It is a data center filled with computers which are always compiling latest software sources, checking them automatically against thousands of automated unit and system tests, and reporting issues back to developers. With this technology, we are releasable every 4 hours.
We were very successful the past years, but especially the past 2 years, the turnover has almost doubled. Which are the challenges to manage this?
We are a stable company. We were never in debts. We never took any credit from the banks. We need to be prepared for growth in the future. We have good partners and good suppliers also. Everything can be done if we have a common goal, be the best on the market.
During the last years we have proven that our system can be used for big-scale projects with thousands of channels. Even more, the system can offer both perfect data acquisition without losing a single sample, and it can be a front-end for real-time control systems at the same time. With this unique combination, the number of projects are growing, even this year in the hard times we are facing.
This was the technical part, but let's talk a little bit about our internal, how we treat people, internal, social offers. What do we offer?
We did a lot of things to make life for our co-workers as pleasant as possible. Restaurant was needed. Like we tried to be perfect with measurement equipment, we also organized the kitchen based on our star cook. The food is great and healthy. This is one of the most important things. And this is what brings us together once more during the day.
I can feel it. Whenever I'm in the headquarters, I can feel it on my stomach. You're really fantastic kitchen. But there is more. We have a very interesting concept to attract our working force. Jure, some time ago you had an idea.
Many years ago, I think 7, 8 years ago, we changed the way to operate the business. We opened the books of the company and defined the rewarding system for all employees. If the company is successful, the employees are rewarded as well. About 5 years ago, we went even a step ahead and we offered with Andre that these rewards can be transformed into the shares of the company with the lowest possible valuation, the book value. Dewesoft is therefore 100% employee-owned, and with this program, more than 10% of shares are already in the hand of employees. This is only one small stone in the mosaic, but an important one that the company is performing great in such difficult times.
You know, we have had a good time in the last 20 years. Thanks for that. And if we believe that we did something good, I can just hope that also customers recognize us like a growing and promising company. If some of the company did not have chance to be in contact with us, I hope that they will try. We are different. We are Dewesoft.
Is it still far?
No, you're just around the corner. Come on.
Come on, I'm dying. Are we there yet?
No, just another corner.
Oh, I can't do it anymore.
Well, there's also a shortcut.
Really?
Yeah, look.
Let's do it.
We've covered a range of technical topics in the last 4 days of BMC. They were mainly focused on test and measurement applications. Today's topic is monitoring solutions, which is the latest development in Dewesoft's solution portfolio. Monitoring has a lot in common with test and measurement, but there are some key differences. As usual, Dewesoft's approach is unique. Let's hear it from our experts. Dino Floriancic overviews monitoring technology at Dewesoft. Dino, please join us on the stage.
Hi, Herbert. Welcome, Dino. Dino, Dewesoft has been very successful in building tools for test engineers for the last 20 years. Why we have decided to also offer solutions for the monitoring industry now?
Well, we have been asked about it by several important customers. Obviously, the monitoring market is huge and we have the underlying technology that's required. Having said that, there was a lot of additional development needed to be able to step into the market. You know, I'm talking about OPC UA, Historian database storage, and the applications on top of that.
So let's start with OPC UA, which is the main protocol for these applications. We prepared a small video to show what it is.
If there exists a common language between machines and devices, OPC UA is the closest to that. It is an open standard that defines information exchange. It is vendor independent and platform independent. It can run on a machine or on a mobile device, and it can connect over a local network or over internet. To utilize OPC UA within Dewesoft X software, there are two plugins available: OPC UA Server and OPC UA Client. The role of the server is to publish the data, and it typically runs on a measurement unit. The role of the client is to read the data from the server and control the server using commands like start and stop acquisition. The client can also change the value of control channels on the server, enabling customized actions. A client can connect to multiple servers, and a server can publish the data to multiple clients. On the server side, we simply enable the OPC UA Server plugin and select the channels that we want to be seen by OPC UA clients. On the client side, we enable the OPC UA Client plugin and enter the IP addresses of the servers. We can then browse the server's information model to select channels or methods that the client should use. When selected, they appear in the Channels tab and can be used as regular Dewesoft channels. Of course, both plugins can connect to third-party systems running OPC UA, making Dewesoft Industry 4.0 ready. The only limitation is that when either a server or a client is not Dewesoft X, the data rate is limited to about 1 kilosamples per second. That is because there is only one data sample in each data packet, and clients will typically send packets with 1 kHz at most. When both client and server are Dewesoft X, the number of samples in one packet is dynamically adjusted, which massively increases the bandwidth utilization. Data rates over 1 gigabit per second can be reached. That is what we call the DAC profile for OPC UA. In addition, Dewesoft's DAC profile makes use of retransmit functionality. If there is a connection drop between server and client, the data is stored locally and retransmitted when connection is re-established.
To me, OPC UA communication seems to have very similar functionalities to the established Dewesoft NET. Is there a difference?
Yeah, the result is similar, but while NET is a proprietary protocol that is purpose-built for Dewesoft DAC systems, OPC UA is industry standard and enables our systems to be integrated into a wider network. Dewesoft NET will still be used in large tests because it can configure measurement units. However, OPC UA is the right choice for long-term monitoring applications where the configuration remains static.
So OPC UA opens up the opportunity to connect to larger information systems and make Dewesoft solutions a part of Industry 4.0. But it is not enough to provide a monitoring solution. For that, we also need a database and several other software components, which we call Dewesoft Historian.
The world is being flooded with sensors. We're measuring more parameters for longer periods than ever before, piling up huge amounts of data. Big data becomes difficult to store, access and visualize, especially when it comes to monitoring production facilities or conducting long-term tests. The challenge is how and where to store the data in order to be accessible from anywhere in the world at any time. The solution is Dewesoft Historian. It enables reliable data transfer from multiple measurement units into a time series database that can be hosted on a server or in a cloud. On the other side, the database can be accessed through a web browser or an instance of Dewesoft X3. The measurement unit is an instance of Dewesoft X3 or Dewesoft RT. It needs to run the OPC UA server plugin to be able to communicate with the database. On the server side, a historian service is handling the communication with the measurement units, writes the data into the database or reads the data from the database and transfers it to the clients. At the core of Dewesoft Historian is a state-of-the-art time series database based on the InfluxDB open source project. Time series databases were developed specifically for long-term monitoring projects with large data rates. On the user side, there are two types of clients. A web client is based on another open source product called Grafana. It provides visualization of long-term data and is accessible on any platform, including mobile devices. In parallel, the database can be accessed by an instance of Dewesoft X3. Using the Historian Importer plugin in analysis mode, the data from a chosen timeframe is loaded into a Dewesoft data file. Alternatively, the data can also be streamed directly from the measurement units to the client, providing a detailed live view. Keep in mind that Dewesoft's retransmit functionality ensures that the data is safely written to the database even in case of network issues. During a disconnect, the data is written to a local buffer on the measurement unit and then transferred to the database when the connection is re-established. Utilizing our experience in measurement technology, we have developed several enhancements for the Grafana web client. Using Grafana within the Dewesoft Historian environment, the loading of year-long data will be almost as fast as loading only a day of data. A special plugin was developed to enable 2D graphs in Grafana for the display of FFTs and waveform scope shots. Dewesoft Historian is a core component of monitoring applications like structural health monitoring and machine condition monitoring, where long-term data analysis is a key requirement. Since the architecture is completely distributed, it enables access between components no matter the location as long as internet access is available. The Historian was even used to transfer the data over a 4G network from an airplane to provide a live telemetry view to several base stations. It can also help you organize the data from long-term tests. Instead of searching through old data files, a central database can be used to store the data in the same format for years. And guess what? Since we are using a well-documented open-source database, you can communicate with it using your own applications to build even more complex monitoring systems. The same is true for the OPC UA interface, which can be accessed by third-party OPC UA clients. Dewesoft Historian brings the data from the most capable data acquisition hardware and software on the market into the cloud for historical and worldwide access, keeping core Dewesoft features intact: reliability, usability, and expandability.
Congratulations to the development team that put all this together. It sounds amazing, but it seems complicated to set up.
That's why Dewesoft has established a monitoring application group that takes care of system installation support. First, there is a detailed manual available, and customers with some IT knowledge can set the Historian up themselves. Second, we can set up the system on the customer's servers.
How does that affect the price for the customers?
Yeah, good question. We have several models. The most basic model is a one-time buy license. The customer buys the license and is responsible for setting it up himself, maintaining the database and working with the system.
I can imagine this will mostly be used by the system integrators as a part of a wider solution for their customers. What about end users? How can we support them?
There is a model that includes our installation support. The price then scales with the number of channels in the database and with the number of clients.
Can we also host data for the customer?
Yeah, we can. If we're hosting the data for the customer, there's obviously a monthly fee for storage and maintenance. And there's more. We can even provide a monthly system buyout. There is a monthly subscription that includes hardware and software, so you don't buy the hardware upfront.
Dear visitors, in case of any questions, please contact our local sales representatives in your country, and our application teams will help you to choose the right models and the pricing issues. Also, please visit our Q&A session after the show here, where we'll be happy to answer all your questions. We learned that Dewesoft Historian is a powerful tool which enables Dewesoft technology to be used in monitoring applications. The most important application areas are structural health monitoring, machine conditioning monitoring. So let's have first a look at the introduction video on structural health monitoring.
Did you know that the majority of bridges were built soon after the Second World War? This means they're fairly old. In fact, there are thousands of structurally deficient bridges in Europe only. Governments don't have the capacity to repair them all at the same time. They need to decide which ones are the most critical. The only way to make a qualified decision is to continuously monitor them. The monitoring campaign needs to be done on a large scale. For that to be possible, the technical solution needs to be reliable, simple to deploy, and cost-efficient. Acceleration sensors are the simplest to mount on an already built structure. They allow us to perform vibration analysis as well as to measure long-term angular deflection. High-resolution accelerometers used to be too expensive for mass deployment, but recent advances in MEMS technology allowed us to introduce a fully distributed vibration monitoring solution, IOLITE-D 3x MEMS ACC. But the sensor is only a starting point. Devices are daisy-chained by a single cable for data, power, and synchronization. There can be up to 100 meters between devices, which can be further extended by repeaters or optics. EtherCAT protocol ensures synchronization down to 1 microsecond, independent of cable length. Network cables with RJ45 connectors are there for fast on-site crimping. The 3x MEMS ACC is also available in a waterproof enclosure for direct outside mounting on the structure. Data from the measurement chain is collected by a powerful Dewesoft X3 software that offers modular mathematical functions from filtering and integration to frequency detection and model analysis. Several visualization tools like 3D graphs and XY plots are available for a quick creation of customized user interfaces. Calculated data can be uploaded to a database for historical data overview and trend analysis. Dewesoft Historian enables a large measurement system with many measurement units across the bridge, or even combining data from several bridges on a central location. The data can be accessed from multiple clients from any location. If additional sensors need to be used, Dewesoft has you covered with a whole product line of EtherCAT measurement devices that fit in the same chain with the 3x MEMS ACC. Anything from strain gauges to temperature or displacement sensors can be connected in the same system. In addition, the software allows simple integration of a video camera or a GPS synchronization source. Even if our systems are easy to use, we know that you, our users, need to focus on data analysis. Dewesoft has a worldwide support network that will happily advise you on how to get the most out of our solutions. From the IOLITE-D 3x MEMS ACC distributed measurement device to powerful software, cloud storage, and worldwide support, Dewesoft structural monitoring solutions are capable of monitoring road and railway bridges on a large scale.
Three times MEMS ACC seems like a nice device. Can it also measure inclination?
Yeah, but only static inclination. This means long-term averaging, like 10 seconds at least. The I&C version needs to be ordered for that because we need to do an additional calibration. We measure the offset drift of the measured acceleration over temperature and then introduce a compensation factor.
Why can't it be used to measure dynamic inclination?
Well, because there's no gyro sensor inside the 3x MEMS ACC. There's only a triaxial accelerometer, so it can only be used to measure static inclination and not the dynamic changes.
Ah, okay. What about this? This is a waterproof version of the 3 MEMS ACC. Why are there no rugged connectors, but only cable glands?
Well, remember that this device is designed for permanent monitoring. It's installed only once and then left in place for years. So there's no point of having a rugged push-pull connector. Moreover, the exact cable lengths are only determined on-site. Therefore, we need a method for fast crimping. RJ45 connectors and network cables allow just that, and the cable glands ensure IP67 protection.
My understanding is that if you want to monitor a breach, the accelerometers are important, but other sensors are needed as well. What hardware should the user be looking out of Dewesoft product line?
Yeah, the IOLITE-D product line offers distributed strain gauge amplifiers as well as voltage and current inputs. You can choose devices from 1 channel to 8 channels, so you waste no channels and each device can be 100 meters away from the previous one. This really is the ultimate solution for structures like bridges.
And as we saw during the day one, we now also have the IOLITE LX that can be used as a remote data logger instead of Windows measurement unit. Is that correct?
Absolutely. IOLITE LX is the device designed for those applications. Of course, it does not offer the mathematical possibilities of a full Dewesoft X software, but it can already satisfy a lot of requirements for structural health monitoring. Namely, it can acquire the data, store it locally, and stream it over OPC UA to the Historian database.
What if some mathematical operations are needed on the LX, like RMS and peak calculation?
Today, we can support this project by project. Customers should contact our sales team and we will evaluate the request.
Can you show us some projects that you have done recently in this field?
We have just implemented elastic shortening monitoring for a new skyscraper that's being built.
A skyscraper construction is monitored using Dewesoft solution. Measurement unit reads strain and temperature signals from static strain data loggers. C++ script module runs calculations on raw data to output 10 parameters that determine the elastic shortening of concrete. There are 170 sensors installed, which means there are 1,700 mathematical channels stored to the database. OPC UA server plugin uploads the data to the database, which runs on a cloud server. A web browser user interface was configured for the live display of data in customer's engineering office. Historical data from each segment of the building can be displayed in specified time intervals. The displays can also be accessed on mobile devices. Data can also be imported in Dewesoft using Historian Importer plugin. It connects to the database and loads a specified time interval into a Dewesoft data file. A predefined setup can be loaded on top. This simplifies the generation of periodic reports that can be saved as PDF files.
What was the key value proposition for the customer in this project?
Mainly the ability to bring the data into a user-friendly interface. There are a lot of solutions for monitoring static strain on the market. Where the customers struggle is at the point where data from a lot of inputs needs to be presented live and be available on demand for a specific time frame, especially if static and dynamic data is combined. The flexibility of Dewesoft X allows us to integrate more or less any kind of hardware. Historian enables us to provide a central interface for the whole monitoring system.
Thank you, Dino, for this interesting new field of applications for Dewesoft, and good luck in developing these solutions further.
You know what I wish?
What?
I had a pair of feet.
Every machine is prone to defects, and therefore a good machine monitoring system is needed to prevent costly maintenance. Dewesoft machine condition monitoring solutions greatly reduce this cost and are very simple to set up and use. Let's welcome Rok Mesar on stage, Dewesoft application engineer, to tell us everything about it.
Hello, Rok. Welcome.
Thank you.
Nice to have such experts with us. Reliability and efficiency are nowadays key elements in production industries to stay competitive. Let's take a look at the introduction video on how the Dewesoft machine condition monitoring solution can help companies improve their efficiency and productivity.
Did you ever think how much production downtime really costs? A lot! Let me give you an example. It is estimated that downtime costs automotive manufacturers around $22,000 per minute, or $1.3 million per hour. Unbelievable, right? Rotating machinery is used in various applications all over the world, providing convenience in our everyday life. However, improperly maintained machinery can suddenly break down, resulting in high maintenance and repair costs as well as lost revenue. In this short video, we will show you how Dewesoft permanent machine condition monitoring solution can help you in preventing sudden machine failures to improve your production availability and efficiency. The Dewesoft machine condition monitoring solution is composed of sensors, data acquisition devices, and machine condition monitoring software. We offer a fleet of data acquisition devices able to read data from almost any kind of sensor used in machine condition monitoring applications. From single channel IP20 or IP67 to connect accelerometers and microphones to multiple channel standalone rack devices or rack-based devices. Dewesoft machine condition monitoring data acquisition product line is EtherCAT based, so combining different Dewesoft products in a single chain is straightforward. Devices can be daisy-chained by a single cable for data, power and synchronization. There can be up to 100 meters between the devices. EtherCAT protocol ensures perfect synchronization down to 1 microsecond, independent of cable length. Data from the measurement chain is collected by a powerful machine condition monitoring software composed of PC client software and high-level web-based software. PC client software offers much more than just overall machine vibration levels. In-depth analysis features essential to detect failures and root cause identifications are available, starting with acceleration, velocity and displacement channels, FFT, spectrum trends, envelope detection, machine elements identification, octave band analysis, torsional and vibrational analysis, and run-up close-down analysis. High-level, web-based software offers an overview of the machinery state and trends over time relevant for decision makers. Setting of alarms, time to email and SMS notifications is also available. Calculated data can be uploaded to a database for historical data overview and trend analysis, or sent over OPC UA to a third-party control system. Dewesoft Historian enables large measurement systems with many measurement units across the production facility, or even collecting data from several locations on a central location. The data can be accessed from multiple clients from any location. Now, let's see how the system works in reality. As you can see, we have built a demo composed of a small electric motor and a gearbox. By changing specific parameters, we will be simulating a real-life situation and will show you the simplicity to detect some of the most common machine defects using the Dewesoft machine condition monitoring solution. Let's run the demo. In order to move the motor, we need to first unscrew it from the base. As expected, the noise floor immediately increases. We are moving the motor in the direction perpendicular to the shaft, creating a parallel misalignment between the motor and the gearbox. The position of the motor was horizontally changed by 3 mm, and the system immediately detected the misalignment. As you can see, the amplitude and the frequency of the motor rotational speed increased in axial direction. Because we have a small motor with a flexible coupling, there are also significant levels of the second harmonic in axial direction. To simulate the imbalance, we will add a mass of 5 grams on the outer side of the coupling, by changing the coupling screw with a longer and heavier one. This will move the center of mass away from the shaft center line and will cause higher vibration at the frequency of the motor rotational speed in radial direction. Dewesoft system immediately recognizes the imbalance and the increase in the overall vibration levels. We will now unscrew the motor from the ground at one of its feet. The advanced Dewesoft solution recognizes the increase in the noise floor of the frequency spectrum, which is caused by a loose foot. As you could see, the Dewesoft machine condition monitoring solution is a powerful tool for permanent monitoring of your critical machinery. It enables production facility owners to reduce production downtime, lowering maintenance and repair costs, and increase company profitability. Just don't overlook the notifications!
Rock, what machine condition monitoring techniques does Dewesoft solution support?
We support almost any technique used in the machine condition monitoring, starting with vibration monitoring using accelerometers or proximity sensors, temperature monitoring, tribology using dedicated sensors measuring oil conductivity, dielectric constant and oil temperature, performance monitoring, using flow, pressure, current measurements, as well as thermography.
Bearing faults are one of the most common faults in the rotating machinery. What kind of technology do you use to detect it?
Bearing faults are definitely one of the most common faults in industries. It is because the vibrations from all the machine parts are transmitted to the bearing due to the fact that bearings hold the machine weight. For detecting bearing faults, we use the so-called envelope detection method.
What envelope detection does, and how do you get the results?
Let me explain by using an example. When a ball hit the crack in the race, the actual vibration that occurs due to the hit has a much higher frequency than the ball pass frequency. The race and the ball basically produce a high-frequency ringing vibration signal, also heard as sound, for a short period of time. The ringing sound frequency is typically between 1 kHz and 10 kHz and has very low energy. In order to analyze it mathematically, we need to first filter out the lower and higher frequencies of the signal and then envelope it into a lower frequency spectrum, also known as demodulation.
That sounds very complex to me. But is it also difficult to use?
Oh no. For easiness of use, Dewesoft machine condition monitoring software offers a large bearing database. The customer just selects the appropriate bearing and all relevant bearing fault frequencies are set automatically. The results are clearly represented in a desired format, table or graphically, as well as thresholds for automatic notifications can be set.
Okay. Do you have any new solutions proposally built to CPM applications?
Sure. Just recently, based on a big automotive manufacturer request, we designed and manufactured a special, cost-effective solution for vibration and temperature measurements. This solution is composed of Iolite 2x ASI data acquisition device and ASI sensor.
Very interesting. Can you tell us more about these instruments?
Iolite 2x ASI is a device with 2 analog sensor interfaces and 1 Techa channel. Up to 2 ASI sensors can be connected. Maximum sample rate is 40 kilosamples per channel. Only a single cable is needed to daisy chain multiple Iolite 2x ASI devices with up to 100 meters device-to-device distance. ASI sensor is embedding a single-axis accelerometer with 0 to 10 kHz bandwidth and a temperature probe in an IP66 aluminum casing. The accelerometer has a range of 50G or 100G. This is a perfect device for machine condition monitoring applications where totally distributed, cost-effective solutions are required.
But also wireless sensors are getting very popular in machine condition monitoring applications. So, do you also provide the solution using wireless accelerometers?
No, not yet. Today available wireless sensors are not yet on the level to be able to perform high-speed dynamic measurements. The main challenges are represented by battery life limitations. Thus, we still rely on wired solutions, however, are constantly following technology improvements.
Okay, I understand. But what about the software solution?
As you know, Dewesoft has always been providing state-of-the-art software solutions. Same is also true for Dewesoft machine condition monitoring software, providing all the necessary tools even for the most demanding machine condition monitoring users.
Dewesoft software is running on Windows operating system. But isn't Windows perceived as a non-stable system for long-term operations?
Yeah, we get this question many times, so we are used to it. The Windows system is becoming more and more reliable. In monitoring applications, when the setup is loaded, it usually doesn't change. This makes the system very robust. For example, in Italy, we have many monitoring applications running several years with zero downtime.
We are often working with system integrators. Are you looking to add new ones as well?
We work with many system integrator companies in different countries around the globe. But yeah, we are always looking to add new, highly skilled ones.
So, what are the benefits of Dewesoft solutions compared to other existing solutions on the market?
You can combine hardware from accelerometers and strain gauges to video cameras and thermography sensors. Then you can use a wide variety of mathematical functions available in Dewesoft. All these data and calculations are perfectly synchronized, even if they are located in different factories.
And can you also stream raw data?
The data is stored in a database that is accessed from anywhere, but the system also allows you to stream raw data from the sensors directly to the client viewer, where you can use it in further mathematical calculations. Competitive solutions on the market are focused on a particular use case, while our solution is really open and expandable for building very complex monitoring applications.
That sounds really interesting. Good luck for these solutions and projects in future. Thanks a lot, Rock.
Are we close yet?
No, we're very far.
We made it, we made it, we made it.
But that stinks. Oh.
Now we have finally come to the most exciting part. Here are the 6 selected best customer case studies. Herbert, the show is yours.
Thank you, Maya. Our first story comes from France, from our partner Clemcy Eiffage, which did a spectacular project, monitoring a complete breach, but a very special one.
Welcome to the presentation of the vibration monitoring system on the Chabandelmas Bridge of Bordeaux. I represent our solution to investigate the sources of vibrations and to increase the overall quality in predictive maintenance on the bridge. This predictive maintenance is done with Dewesoft data acquisition and with the big data processing solution Smart Forest by Clemcy. The challenge was to define the best DAQ architecture and monitoring technology for this instrumentation with long cable length and to interconnect the Dewesoft data acquisition solution to the Clemcy database. In 2003, the project requirements for a new bridge to cross the river in the city center of Bordeaux, France were: provide a crossing over the river Garonne for cars, pedestrians and bicycles, as well as, at a later date, a tram line, and allow the passage of boats and, in particular, very large ships. The result of the project is the Pont Jacques Chabandelmas, the longest vertical lift bridge in Europe. Its main span is 110 meters. The construction took place from 2009 to 2012, and the bridge was inaugurated in March 2013. Bordeaux, in southwestern France, with almost 1.2 million inhabitants, is a port city on the Garonne River. The architecture firm of the bridge is the SARL Architecture et Ouvrage d'Art. The design of the work and the project management within the Design Realization Consortium, led by the GTM company, are carried out by Aegis GMI, the architects Thomas Lavigne and Christophe Choron, Ardesti and Hanover, and the design engineer Michel Virlangeux. The bridge has been named in honor of Jacques Chabandelmas, who was a general during the World War II, mayor of Bordeaux, and Prime Minister of France. The bridge is 575 meters long, 433 meters of which is the main deck, and 117 meters is the central lift span. The central section of the bridge remains in one piece, but lifts vertically up by to 58 meters to let tall ships pass underneath. The weight of the lifted part of the bridge is around 2,600 tons. 40 ropes of 69 meters in length each connect to this center bridge segment via deflection pulleys at the top of 4 pylons using counterweights. The bridge is configured for up to 43,000 vehicles a day. The bridge rises about 60 times a year. It takes just 11 minutes to fully lift or lower into place. Here, you can see the view from the top of one of the towers of the Chabandelmas Bridge. Now, let's talk about predictive maintenance and permanent monitoring. Operation and maintenance of the structure is the responsibility of the company Eiffage Energy System (CLEMC), a branch of one of the top 5 biggest construction and concession companies in Europe. Eiffage CLEMC is specialized in the engineering and implementation of industrial technical installations. The lifting mechanism works on the principle of a giant elevator and requires the participation of a team of 10 staff members. From a control tower, 2 operators manage the maneuver, while the rest of the team is spread over the various strategic points in the foothills of the bridge. In addition to this, the team manages the maintenance of the vital machinery, motors, shafts, huge cables, and pulleys. To increase the overall quality in predictive maintenance, we have decided to install sound and vibration sensors to monitor the kinematic chain, the machinery, as well as the main pulleys on each side of the bridge. The bridge is mainly instrumented with IEPE sensors, accelerometers, and microphones, while current sensors and tachometers are only used in the machinery instrumentation. Now, the interesting part begins, the measurement setup. Things to look out for can be vibration and inexplicable noise, such as knocks, which are phenomena below 10 kHz bandwidth, so the maximum required sample rate was 20 kHz, which fitted perfectly with the maximum sample rate of Krypton, a reached and distributed EtherCAT data acquisition system for field measurements in any environment. Krypton DAQ systems have an IP67 degree of protection and can operate in the extreme temperature range from -40 to +85 degrees. The whole instrumentation is 82 analog input channels separated in 2 sides of the bridge, 41 channels for each side with 2 pulleys. This application required the math processing tools of Dewesoft X3 data acquisition software to calculate real-time statistical parameters on each vibration sensor. The point of interest for the investigation was not the time channels, but from each input sensor the customer required to calculate statistical indicators to compare with alarm levels. An alarm counter written in C++ has also been implemented for this project. The challenge was to define the best DAQ architecture for this instrumentation, as some sensors are located on the top of pylons for the police monitoring. Each side has 2 pylons, and these pylons are 77 meters high and no source of power is available on the top. Krypton modules based on EtherCAT protocol technology allow having a cable that can run up to 100 meters from module to module, connecting amplifiers together. A single cable is used to transmit data, power, and synchronization between DAQ modules. Rugged DAQ module and EtherCAT were the 2 main reasons to select Krypton DAQ modules. These were the only solutions to place the data acquisition system on the top of each pylons without big investment. Connect DAQ system with existing database OPC UA. We have seen how we go about obtaining the data necessary for predictive maintenance. But a problem persists. How to use this data? This is what I will explain to you in this second part. Indeed, the other challenge, and not the least, was to interconnect the Dewesoft data acquisition solution to the database over OPC UA to exploit the data in an Internet of Things IoT solution. OPC Unified Architecture OPC UA is a machine-to-machine communication protocol for industrial automation developed by the OPC Foundation. This standard is frequently used in Industry 4.0 for communication and data sharing between different devices. During bridge lifts, the condition-based maintenance team members are not situated in front of Dewesoft, but use a specific local web interface with only statistics and reports about the maneuver. The CLEMC database collects information from the Dewesoft OPC UA server, such as alarm levels, alarm numbers, shock counting, statistic level for accelerometers, microphones, and the AQ status. CLEMC database solution is called Smart Forests. More than a single database, Smart Forest is a global solution, including a big data software platform, a multi-channel, multi-source interface for data collection, an artificial intelligence engine, a modular and user-friendly HMI. Smart Forest is a visual interface for web interfaces displaying values for alarm levels, alarm numbers, shock counting, statistic levels for accelerometers, microphones, and the AQ status. Conclusion. Dewesoft and CLEMC were able to offer complete hardware and software solution for the entire bridge data acquisition and monitoring instrumentation. The software is intuitive and very easy to use, and it includes 82 analog channels, 800 match calculations, 800 alarms, and beautiful display. The same system can acquire analog data, make the calculations, check the alarm level, and transmit the data using the latest communication OPC UA protocol to present data in a smart user interface. The monitoring and maintenance of bridges have become real strategic issues for CLEMC. Unfortunately, we have many examples of bridge accidents due to lack of maintenance, such as the Genoa Bridge in Italy on June 28, 2019, which collapsed. The realization of this project is a concrete showcase of the solution proposed by Dewesoft and CLEMC. I will conclude with a short time-lapse video of the final results. Thank you for your attention, and we would be happy to answer your questions.
Wasn't that spectacular? Thanks a lot to CLEMC Eiffage, our partner, who realized this project with us. The next story now we got from Italy. You know, Italy has many geothermal power plants. And to use geothermic is a very ambient-friendly way for energy production. So it's more or less a future in energy production. And the project we realized together with our partner there is spectacular in a way that we monitor the total entire power plant. Hundreds of channels and even more mathematic channels, alarm monitoring, condition monitoring, all comes together. Over the period of 3 years, we developed this solution. Now, let's talk to Matteo. How is the background? How did that develop over the past 3 years?
I am Matteo Galgani, I work at Enel Green Power. At the present moment, I'm here now at Larderello plant that can be considered the world capital of geothermal energy. When more than 100 years ago, geothermal energy was used for the first time ever to produce electric energy. Smart Geo is for us a very important innovation project and technological advancement for our production plants. Smart Geo is a co-financed project by European funds through the Tuscan region, where we collaborate with local excellence. Academic excellence thanks to our collaboration with Florence University and Sant'Anna School, but also industry excellence like SDI and ISE. Smart Geo main goal is to follow Industry 4.0 concepts and apply these technological solutions in our plants. Dewesoft represents the right solution for flexibility, scalability and reliability. ISA and Dewesoft have developed an innovative solution perfectly integrated with our power plant systems. Curious about more details? You have just to vote for our story.
Thank you, Matteo, and best regards to Italy, to you and your team. The next very interesting applications arrive us from Czech. It's a sound intensity measurement, but fully automized. And David Kohut did send us a very interesting story about it. Let's have a look. How much effort was put into this project in terms of programming, setting up everything, and handling the robot who did the measurement automatically?
Thank you, Marketa.
Majority of the time took programming the collaborative robot and creating universal approach that can handle different machine shapes and sizes. Interfacing collaborative robot with Dewesoft series amplifier was easy and straightforward. The creation of the measurement setup in Dewesoft software as well as adjustments of the plugin for intensity probe was quick. Many thanks to Dewesoft support for their quick response and hard work. The last part of the project was how to export the data and create repeatable report from the measurement. I used Dewesoft Microsoft Excel template, which was very efficient. For example, I was able to create 3D graph of the velocity field in few clicks. This seamless synergy with Microsoft Excel allowed us extend data post-process capabilities even further.
And how much of a testing time can be saved now?
It's hard to come up with number of hours we saved. As we were unable to do this magnitude of measurement in the past, the main benefit of this solution is massive improvement in measurement mesh resolution and improved repeatability. This method now provides enough data for the CFD models, development and calibration. Once the system has been set up, we can compare many design iterations in very short time. On the other hand, preparation of the measurement setup takes about 2 hours, which make it slightly overkill for individual short measurements.
Thank you, David, for this really interesting application. Can you tell us at the end, why did you choose Dewesoft?
The Dewesoft system unifies all measurements across our test department. It simplifies our work and improves our testing flow. Thank you and goodbye.
The next application is as well spectacular. It arrives us from US to monitor the biggest vehicle in the world, the NASA rocket space crawler, who transports the huge rockets from Cape Canaveral to the launch pad. The difficult part in this project was to do the time correlation of all those signals using IRIC signal, and then correlate all the data and monitor it in real time and distribute it to many monitoring stations. Let's talk to Jake Rosendahl, who was project leader from Dewesoft site in Florida. Hello, Jake. This is a fantastic vehicle. What was the challenge in this project?
Hi, Herbert. Thanks for having me. Really excited to talk to everybody about what we're doing at Kennedy Space Center with NASA and Dewesoft. The crawler is an awesome vehicle, carrying around as much weight as it does. And so what we're really looking at and what Dewesoft's been doing is we've gone in and replaced a very old data acquisition system that's measuring the hydraulic pressures across the system for being able to move and level 12 million pounds, and then also doing some low-level vibration measurements to be able to tell structural integrity and be able to see what's going on to make sure nothing out of the ordinary happens. So they are looking for keep everything within tolerable limits, because if anything alarms and anything with these measurements, they need to stop and figure out exactly what's going on. When you're carrying 12 million pounds around, don't want anything really going haywire or anything at all different.
So it's an important task for Dewesoft equipment to ensure the safety of the rocket during transport. Jake, does NASA also use other Dewesoft equipment in other applications?
Yes, Herbert, there's actually a lot of fun things we're working on Kennedy Space Center with. One unique thing, people think, Kennedy, they just launch rockets, right? No, they're actually tasked also with recovering the Orion capsule after it splashes down in the Pacific Ocean after everything's all said and done. Like everything with space travel, nothing can be easy, and it all has very unique challenges. And because the Orion capsule, it's fragile. It's designed to fly through space and come back safely, but it's not designed to be lifted and moved around except by a rocket. So it wasn't designed to actually be lifted out of the water like the old Apollo or the Gemini Mercury capsules by a helicopter. Those were designed to have the structural integrity to be picked up by the top. The Orion capsule cannot. It's too big. It carries too many people. And so they're going to, instead of trying to pick it up out of the water, they're going to let it float. And there's these Navy ships that actually can have the back end where hovercraft normally go in. They flood with water and they put a cradle in there, and they're just going to simply float the capsule with ropes, pull it into the back of the ship, and then be able to set it down on this capsule and keep everything nice and calm to preserve the capsule. So with all these challenges, they're trying to figure out the best way to pull it in and secure it. Well, so what we're doing is we have instrumentation that they put inside the mock capsule, that we have a Dewesoft system in there that has an IMU, and we're watching roll, pitch, and yaw and position of the capsule. And then we're also measuring load pins of where the ropes that are getting attached to the capsule to be pulling it into the ship, what loads are being put on the capsule to make sure they're not going to damage it. And then simultaneously, while we're measuring on the capsule that's floating in the water, they're measuring on the winch pulley systems that NASA designed inside the ship to see what kind of load they're exerting from the winch systems and what they're doing in movement, to then be able to see a total look using Wi-Fi that you have two Dewesoft systems, one in the ship that's measuring the loads of the winches, and then what the actual impact of that is real time on the capsule as they bring it in and try to secure it. And as you can see in the videos, it is a very difficult challenge with different wave things, even when it looks like a calm ocean. Really cool, neat application that we get to play in as well.
Thank you so much, Jake, for these great applications. It's always very interesting to see what you do up there in the US. Greetings to all the team over there, and yeah, have fun.
We have two more interesting case studies that will for sure catch your eye. I would like to welcome on stage Mr. Reinhold Fink, Dewesoft Sales Manager for Asia and Pacific region. Reinhold, welcome.
Good Asian style. Welcome,
Yes.
Reinhold. Please.
Thank you.
Take a seat. Hello, Reinhold. You joined Dewesoft almost 10 years ago. You have started as a leader in research and development, and today you are supporting all our offices in Asia Pacific to find the right technical solution for our customers. Where do you see the driving economy in Asia?
Herbert, I don't think we need to differentiate between the different continents. We all share one globe, and the main goals for everyone is the same. One of the global topics is how we deal with the limited energy source on our globe. We need to take care which energy we are using in the future and how we can save the energy as well.
But how does this relate to Dewesoft data acquisition solutions?
We don't produce energy, but we help with our solution our customers to develop their products in the most efficient way. Let's take a look on the automotive industry. Almost the whole world is changing now from the typical combustion engine to e-mobility, starting from US with Tesla, as well as all OEMs in Europe, but the real driving force is China. China is both the largest manufacturer and buyer of electric vehicles in the world, accounting that more than half of all electrical cars made and sold in the world. It starts already in the 1990s with the development of electric bikes and motorcycles. And 20 years ago, the development of e-mobility was initialized with the E63 EV project. And since 2009, China is worldwide the biggest automotive manufacturer. Nowadays, 1 million battery and hybrid cars are produced in China per year. China makes also 99% of the world electric buses. At this point, I would like to welcome Jackie Ma, Manager of Dewesoft China, on stage, virtually, like all of us. Jackie, please let us know how Dewesoft is used to save energy in the mobility market.
Main goal is very simple: increasing the vehicle mileage. In other words, expanding the driving distance with a fully charged battery, with decreasing the need energy per kilometer, which is the more relevant when the number of vehicles in the market rises. To achieve this, the efficiency of the complete energy flows must be measured. Let's say starting from the charging station to the battery, then followed by the power distribution unit to the main customer, the motor control unit. Then also all the other consumers like air conditioners, heating, lighting are also very important. Finally, it is also the mechanical power of the motor, which is needed to be considered. With these measurements, you get a complete picture of the efficiency and you can optimize your vehicle. For the whole application, Dewesoft provides the needed sensor as well as the data acquisition system. Starting from high voltage DC path to the high frequency motor current to all other low power consumers can be analyzed with our devices.
Jackie, where do you see the biggest advantage of our solutions?
I think many tests under various conditions must be performed. For example, on different temperature or different load conditions. Dewesoft calculates all results online. There's no need for post-processing of data. These maneuvers are performed at the testbed, where the Dewesoft provides many different interfaces to the testbed controller. The compact size of the Dewesoft power analyzers also allows as well the usage in the vehicles for public road testing. Dewesoft Simple provides more than just a power analyzer. You can measure any signals or ECU data to get the complete picture of your testing vehicle.
Jackie, we all know the actual batteries are the weakest point in any vehicle. How do you see the need of this energy measurement in the future?
Actually, even if the classical lithium-ion battery is changed to future fuel cell or hydrogen source with higher energy, actually such kind of efficiency measurements will stay important.
Thank you, Jackie, and to the whole team bringing our technology to our customers.
Thank you very much for your invitation. Yeah.
The next challenge now is to provide enough electrical energy for the chargers. This is especially difficult in areas with high density where we need new innovations and new technologies. But this is another story.
So, let's talk about the other story. What else do you see as a global topic?
The next global topic is providing the infrastructure for the worldwide communication. Especially in these times with COVID-19, it's very important. We couldn't even hold our virtual measurement conference without having this infrastructure.
Yes, that's true. But how is Dewesoft related to the communication market?
Even our mobile phones would not work without hundreds of satellites. So-called satellite launch vehicles, these are basically rockets, bring them to the orbit. India is playing a major role in this field. I imagine at least some visitors might be surprised now. But India is much more than just the Taj Mahal, the crown of the palace. The 5,000 years old history of yoga in India shows their spiritual motivation starting already in the childhood. It is also more than cricket, by far the famous sport there, almost a religion, played by more than 5 million people. India, with their 22 official registered languages, is the biggest democratic country with the higher population than Europe and US together. But this unity has also exponential growing economy. Besides the known software industry, ISRO, which is the Indian Space and Research Organization, is one of the industry segments. In the year 2017, ISRO has created history by successfully launching 104 satellites on a single mission, overtaking the previous record of 37 satellites. All but 3 of these satellites are from foreign countries. most of them from the United States. This is a sign that India is emerging as a major player in this multi-billion-dollar market. Now I want to welcome Mr. Dhiren Varghese, Managing Director of Dewesoft India, on stage. Dhiren, what is the role of Dewesoft at such launches?
Regards from Dewesoft India. You can imagine many tests are needed before a successful mission. One of the major tests is structural dynamic test of launch vehicles. The data for more than 2000 channels has to be captured during the test run.
Dhiren, Dewesoft India was founded only 2 years back. How could you build up the trust with the customer within this very short time?
Dewesoft has been successfully represented in India with several partners for the past 10 years. One of our major partners is Innovative Solution. Let's welcome Mr. Shaji Gopalakrishnan, Managing Director, Innovative Solution. Hi Shaji.
Hi Terry.
Please give more details about this project.
The project is meant for qualification of Indian Space Research Organization satellite launch vehicle structure which carries the payload as satellite. The main motive of this project is to obtain the data at the highest accuracy from sensors like strain gauges, pressure sensors, LVDTs, RVDTs through Dewesoft Precision Signal Conditioner. In addition to the local acquisition and storage, the architecture for redundant data streaming is important to ensure data quality in critical test cases for ISRO. The entire data stream is then merged with the Dewesoft net functionality and transferred to the control room via fiber optic channels, allowing seamless data visualization of all data from remotely located view client system.
Shaji, what do you see major advantage of Dewesoft system for this application?
Well, Mr. Dhiren, the major criteria for such a large system is the perfect synchronization of all the data is the main criteria. Apart from that, the accessibility of all data from a single point of view and retrieval of stored data for analysis by using Dewesoft X application makes the process for the user much easier. The field-proven Dewesoft hardware and software, which is the best-in-class signal conditioning, and to top it off with the best isolation techniques. We also provide for each channel the real-time EtherCAT output for direct interfacing to any third-party EtherCAT master like PLCs to avoid hassles of wiring for 2000 plus analog output. We provide locally the complete system integration, including sensor wiring, local calibration, and the service and maintenance of the entire project.
This is the result of 8 years of hard work. Thank you.
Thank you, Sashi. Thank you, Dhiren, for this amazing system concept. For this project, we combined together our experience we got over the last 20 years out of many, many small applications. This was just a combination of these other projects.
Thank you very much, Reinhold, to you and of course your teams in Asia Pacific, which do a fantastic job. Thanks a lot.
Hey, Herbert, you promised us something.
Yes, Herbert, you promised us we could select our favorite case study.
Yes, guys, I promised. You can pick your favorite case story, but you need to explain why you choose this particular one. Ready?
Don't you just hate when you go to the shop and dream about making a perfect guacamole?
Oh yes, I would die for guacamole.
Except when you buy a perfect avocado, just until you cut it open and then it's half rotten or not ripe yet.
Yes, that's so holy guacamole moment. I hate it.
Well, from now on, nobody will have to anymore.
Ever? Never, ever?
Never.
Woo!
Thank you, Socks. As I did understand this application, you check the avocado if it's ready to eat using radio frequency. When the avocado gets ready to eat, it becomes softer and softer and creamier inside. But how to measure that without touching? So let's call Gabriele and Sara in Roma to find out more about the non-destructive monitoring of fruit ripeness.
Sara.
Thank you, Sok.
Ah, your phone is ringing.
It's Herbert.
Herbert.
Hi, Herbert. How are you? I'm fine, thanks. I'm with Gabriele. We will be at the office in 1 second.
Sara, Gabriele, you did develop something very special. Can you tell us more about?
Yes, Herbert. We developed a prototype of a totem to monitor the status of the fruit. We shot a video of it. Did you see it? Let me send it to you.
Sara, congratulations, this is a great idea. Are you happy about the result?
Thank you, Herbert. Yes, we are very happy about it. And even the customer is quite happy. But now the challenge is that we have to improve the accuracy of this system.
Yeah, but how to improve that? You might need new ideas.
So we found that the electrical properties of the fruit will change with the ripeness process, and we expect a similar phenomenon also with the mechanical response of the fruit. So a possible solution could be a multiphysics approach that combines the electromagnetics analysis with the mechanical one. So, Gabriele, do you have an idea?
I don't know. Something like this?
Come on, Gabriele, you are a creative person.
I think I have an idea. Wait. We could use a shaker to excite the structure, place the fruit over the shaker, and an accelerometer over it. So we could measure the transfer function, the mechanical transfer function, and we could use a Krypton module to measure the signal.
Herbert, I think Gabriele found a good solution. Let us work on it.
Yes, Herbert. I will keep you updated. Bye-bye.
Ciao.
Thanks, Sara and Gabriele. We're looking forward to present the result at our next conference. Best greetings to Roma.
Dear audience, after 5 exciting days, we are slowly coming to the end of the Virtual Measurement Conference 2020. I would especially like to thank to all of our great customers for sending us so many amazing stories from all over the world. And thanks to all of you who were patiently watching us for the past month. Dewesoft will continue to innovate and create new cutting-edge technologies for you. Together, we can make this world a better place and keep creating all of the amazing products that we can all enjoy. Out of all these interesting stories, we've got a winner.
I'm proud to announce the best case story. And the winner is Indian Space Research Organization.
Congratulations.
Congratulations to India. And again, thank you all the other countries and customers who sent us so exciting case studies and application stories. After 20 years, it's still so exciting to work for you, for the customers, but it's still passion. It's not just work. We don't feel it as work, it's passion, what we do here. And so I want to also thank you, the teams here in the headquarters who prepared this for this measurement conference, but also the teams out in the countries which are here for you, your most valued customers.
We have come to the end of Virtual Measurement Conference 2020. I hope you enjoyed it. We climbed the tallest chimney in Europe, the tallest mountain in Slovenia. We have destroyed a washing machine and have blown up a car. That was nice, but for me, the highlight is still coming up. For the very end, Sasha and Dewesoft Orchestra, consisting of only Dewesoft employees, prepared a special performance for you. And you may ask, why are we doing all this? Why can't a measurement conference consist of just plain technical videos and discussions? Why did we invent the Dewesofts? What are the beautiful ladies doing here? Why is music so important for us? For us, Dewesoft is not only a company, it's a way of life. It's a passion of trying to do everything in our power to fulfill customer requirements and to help in developing new cars, trucks, airplanes and exploring space. In short, to help humanity evolve. The best products are always a mixture of hard work coupled with fun, and we can promise that we will continue to have fun with what we do the best, measurement instruments, simply because we are Dewesoft. Sasha and Dewesoft Orchestra, let's rock!